Okay, we are back again. It's May 26th. We're looking at solving two-step linear equations, and today we're going to look at the tough ones. Just so you know, the way I'm going to mark this assignment that's attached to today's lesson, these ones are on the difficult side. There are a few of them that I definitely want to see answered. I don't want to see them missed. Okay, they're important. Got to learn how to do two-step linear equations. The rules are the same, but I'm picking 4 examples straight off the worksheet. These 4 I want to see that you've written down and attempted. So number 7 is the first one we're going to start with, and we're going to start with some of the ones that are a little bit more complex, and they are maybe a little bit more difficult to see because it looks like you have to do something that's kind of an exception to what we talked about. Again, when we solve an equation, we want to find out what j is in this first one. So the whole equation is j subtract 10 divided by 3 is equal to -4. When you have ones that are set up like a fraction like this, you actually have to do something a little bit different, and you have to change it from fraction form. So the way we do that is by eliminating the denominator. So we need to multiply both sides by whatever the denominator is. So since the denominator here is 3, if we multiply the left-hand side by 3, then that's going to leave us with j subtract 10 equal to -4 times 3. Don't forget your integer rules. And then we have an equation that's going to look like this, j subtract 10. And then we can just go on like normal, and we don't have to worry about that dastardly denominator. So the opposite of subtract 10 is add 10. We're going to do that to both sides. Remember the principle of balance, very important. -12 plus 10 is -2, and then boom, there's our solution. So it pops in right there. So integer rules, very important, okay, for addition. Don't forget about those as we go along. Very important, importante, muy importante. Okay, let's get on with the second one. So stop and think about this one. This one is from the same worksheet from today, number 9B. So 9B, it's set up, it looks like it's a little bit fractional, and the denominator has something attached to it again. So if we were to just subtract 8 right now, that's going to give us the wrong answer. We need to get rid of the denominator. And it looks like the denominator is -2. So remember, this is like a divide by -2. So our first step is going to be to multiply by -2. Not just 2, but -2, because we want to eliminate that denominator. So x plus 8 divided by 2, we're going to multiply by -2, and we're also going to multiply this side, the right-hand side, by -2. So this will eliminate the denominator. Positive times negative is -20, and then we have just a simple single-step equation left, which we've always dealt with, and you guys did great with those ones. So we got x plus 8 subtract 8, -20 subtract 8. So x is equal to -28. Okay, so I bet you if you have trouble with anything, it's probably going to be the subtraction step with integers at the very, very end, because you just, need to review those. Very common. All right, we're actually going to do a couple of extra examples today. Again, these ones are straight off the worksheet, so you can get a feel for how to do those ones. This one is 8C, number 8C from today's worksheet. Here we've got -5r plus 13 equals -17. I picked this one for you for a couple of reasons. One is because of the negative in here, but now we got to flip back, and we're going to use the reverse order of operations again. We are going to deal with the adding 13 part first. So we need to subtract 13 from both sides. My pen is running out. My pen, I can tell, it's drying out. And when this pen gives out, math is done for the end of the year. If this pen dries up, then math is finished for the end of the year. Just kidding. I got an extra pen. Sorry, Kate. Negative 17 subtract 13 more is going to leave us with negative 30. Now, I picked this one to show you because we do need to deal with this negative 5 times r. And that means both sides have to be divided by negative 5. Not just 5, but negative 5. So negative 5 divided by negative 5 is 1. And r is going to be equal to positive 6. Why positive 6? Because a negative divided by a negative is positive. Okay. Now this one's a little bit weird because of the order. If you look at it, it looks like the numerical part is at the front end, and then we're subtracting this fractional part. Looks kind of weird. Now this one does not have, and this one comes from 13B on your assignment today. This one's a little bit weird. How are we going to deal with this bad boy? Well, we're going to deal with the bad boy by eliminating the 28 first. Now this is plus 28 here. So if we took this side and we subtracted 28 and then did that from the other side, 28 subtract 28 is going to leave us with negative d divided by 70 on this side. And that's why I picked this one. I don't want you to lose sight of this subtraction thing. We can't just arbitrarily get rid of negative signs. If a negative sign is there in one step and we haven't done anything to eliminate it, it's got to be there in the next step. So that's why I picked this one for you. So 56 subtract 28, I think last time I checked, that is positive 28. Positive 28. Then this is a bit of a weird one here because now we got this, I don't even know if I wrote this one down correctly. I feel like this is a little bit off, but whatever. So we got divide by 70. So the opposite of that is multiply both sides by 70. So that's going to give us negative d. Remember, I picked this one because we do need to keep this negative one in play, all right, until we eliminate it with some kind of an operation. Now, if you go check that out, our next move is going to be 28 multiplied by 70 of all numbers, which ends up being 1,960. But think of it this way. Think of this negative sign as being the words, the opposite of d is 1960. The opposite of d is equal to 1,960. We don't want to know what the opposite of d is. We want to know what d is. So then d is equal to negative 1,960. We could go back, we could verify that and see if that is actually the case. This one is worth verifying just in case we blew it with the negative signs. So let's verify this one by substitution. We've got 28 subtract negative 1960 divided by 70. We're going to ask the question, does that equal 56? The value on the right-hand side. Okay, so this is our checking step. This is our verification step. So let's do this part here first. Negative divided by 70. So if you work that out, remember that part, you can definitely use a calculator for them, all for that. So this would be 28 subtract negative 28. Does that equal 56? And if you remember your integer rules, taking away a negative is like building a positive, and 56 is equal to 56. So our solution was correctamundo, okay, negative 1,960. All right, so we're going to stop the recording here for today. Make sure you get that assignment done. I want to see some answers for these 4 questions, and I want to see you do at least 4 or 5 more. If you do them all, then that's great. There's a lot of questions on there. I understand that. That's why I'm giving you 2 days to complete this assignment. Okay, 2 days instead of just 1. So I'll see you back again on, I guess, Thursday. All right? Have a good day. I'm going to have more coffee.